Hello friends, welcome back to my YouTube channel Learner AK. Let's start now friends. Today we learn using D-Alembert principle of an Lagrangian equation of motion. First of all, we know D-Alembert's principle. If a system of a particles, the total force Fi vector the ith particle can be split to Pi before into first Fi the force of constant and second number Fa vector is the applied force. By Newton's second law, we obtain Fi vector is equal to Fa vector plus Fi vector is equal to Pi vector. This is the equation 1, where Pi is the linear momentum of ith particle of the system. The work done in a virtual displacement of the system is given by sigma F vector into del Ri vector plus sigma Fi vector into del Ri vector is equal to sigma Pi vector del Ri vector. This is the equation 2. By the requirement of anything of the virtual work done by all the constant forces, we have del W is equal to sigma I Fi vector into del Ri vector is equal to 0. This is the equation third. So we have from the relation sigma I Fi vector minus Pi vector into del Ri vector is equal to 0. This is the equation 4, where minus Pi appears as the effective force called the reverse force of inertia on the ith particle. This equation is commonly called the D-Alembert's principle. And we know, friends, Lagrangian equation of motion. Let a holonomic dynamical system consist of n particles and have n degrees of freedom. The coordinate transformation equation in terms of generalized coordinates are then Ri vector is equal to Ri vector into Q2, Q1, Q2, Qi, Qn. Velocity of the ith particle in terms of Qj is given by Vt vector is equal to dri by dt is equal to sigma j del Ri vector by del Qj plus del Ri vector by del t. This is the equation 2. Consider now the infinitesimal virtual displacement del Ri vector at a particular instant t. It can be linked to del Qj del Ri is equal to sigma j del R by del Qj plus del Ri by del t is equal to sigma j del Ri del Qj. This is the equation third. Since for virtual displacement del Ri vector by del t into del t is equal to 0. If now the ith particle of the system is acted upon by an applied force Fi vector, dropping the superscript A, and if minus Pi be the reverse inertial force, then from D-Alembert's principle we obtain sigma I Fi vector minus Pi vector into del R is equal to 0 force. This is equation 4. Sigma j Fi, and then sigma Ri vector by del Qj minus sigma j Pi into del Ri by del Qj vector into del Qj is equal to 0, using equation third. And then we obtain sigma j qj del qj minus del I sigma j pi vector into del ri vector but del qj into del qj is equal to 0. This is the equation 5, where qj is equal to sigma t into fi into del rj by del qj. This is the equation 6. Is called the generalized force as it follows similar role to Fi vector into in del W the virtual work done by Fi vector. And then friends, you obtain equation 7. We can see that since Ri is the assumed to the continuous second order partial derivative, but we have again you can see now. And then you obtain equation 8 using the relation equation 2. This shows that the order of differentiation with respect to t and 2 can be interchanged. So one differentiation of formation equation, and then we obtain equation 9. Subtracting equation 8 and 9 in equation 7, we obtain, and then d by dt del t del qj minus del t by del qj, and then this is the equation 10, where t is equal to sigma I 1 by 2 mi vi square represents the kinetic energy of the dynamical system. Thus, the D-Alembert's principle become. Now obtain, this is the equation 11. Because of constant del Ri are not independent D-Alembert's equation, but del Qj equation in equation 11 are independent as the constant they are assumed holonomic, so the coefficients of each del Qj must separately vanish. And then we obtain equation 12. These n equations are known as Lagrangian equation of motion. It is interesting to note that Lagrange recovered this minimum number of independent equations of motion from just once D-Alembert's principle. For conservative system, force can be derived from a scalar potential functions v of position only them. Fi vector is equal to delta vector iv is equal to minus del v by del ri. Qj is equal to sigma I fi del ri vector by del qj is equal to sigma I del v by del ri, and del ri vector del qj is equal to minus delta del v by del qj. This is the equation 13. With the introduction, v Lagrange's equations becomes del d by dt into del d by del qj minus del t by del qj minus del v by del qj is equal to 0, or d by dt del l by del qj minus del L by del Q is equal to 0. This is the equation 14, where L is equal to T minus B. This is the equation 15. The quantity L T minus B is known as the Lagrangian of the system. Equation 14 are usually called the Lagrangian equation of motion or conservative holonomic motion. Thank you, friends. We meet in next video.